All right, I suppose we can go ahead and get started. So welcome, everybody. This is our second technical architecture forum for Konveyor. Again, this meeting is all about sort of presenting technical concepts, solutions, trying to find areas where we can work together, and having in-depth technical conversations and discussions around that. If you look at the agenda today, we're actually going to start with, and we'll see how far we get, but we've got two things on the agenda today, and again, we'll see how far we get. But we're going to start with kind of a continuation from some of what we talked a little bit about last week with Sean, kind of talking a little bit more about transformations and best practices in that area. And then if we get beyond that, Jill is going to talk a little bit about some work that's been going on in our space with VM migrations around VM inventory. So let's just see sort of how the conversation goes. But to start off, I'll turn it over to Sean and let him drive us in this transformation discussion.
Cool. Thank you. Wait, can you guys hear me?
Yep.
Like that's a no. Yeah. Okay.
Yep.
So present now. So I put together some slides. Make sure that can everybody see the slides okay?
Yep.
Cool. All right. So wanted to talk through the high-level problem around transformations. So the reason that we need transformations, at least in MTC, and other such anything that is going between two different Kubernetes clusters is basically that Kubernetes clusters can look and feel very different based on a combination of things. Node names, node taints, different RBAC rules for SEC, different versions of an API. There's lots of different ways that even if you have exported a Kubernetes manifest from one cluster to a different cluster, it may or may not be applicable to the different cluster. So that's the high level problem. I kind of want to pause there and see if there's agreement on that statement, or if we want to dive into that some more.
Sean, just add to that, I think there is other use cases from, say, move to cube or something perspective, where we have cases where for an existing artifact, people want to add some metadata to it, depending on the organization guidelines or something.
And by metadata, what are you referring to?
Like annotations or labels and stuff.
Yeah, I think that's all part of the same idea, right? Is that
Right.
that cluster A might not need that, but cluster B maybe needs a new annotation for like your ingress, right? Because you have a different ingress controller in cluster B. And even though you have an ingress, maybe you need to add some annotations to make the new ingress router work, right? Like these are all it's the same effective idea, which is that and SECs are also annotations. So yes, I agree with you. Annotations and other such things, like when you go from cluster 1 to cluster 2 might need very different information, and that includes the annotations or labels or whichever else. So I agree with you. I didn't call it out specifically, but that's yes, 100%.
Sure.
Anybody else? Okay, cool. So one of the things I wanted to talk about was like a common example of this. And so let's take this Tomcat pod that we've scheduled into cluster 1. Basically, the scheduler adds the node name to the pod to tell Kubernetes where to put the pod and run it, well, the kubelet. But when we export that pod from cluster 1, we have to remove the node name from that pod spec, before we can schedule it on cluster 2 because cluster 2 doesn't have the same nodes as cluster 1, and it won't be able to schedule that pod because it will be attempting to look for a specific node, and it will say like, that node doesn't exist, I can't schedule the pod. So this is a one very specific use case of the overall problem, which is that cluster 1 has very different information than cluster 2, and we need to change things to take an exported YAML manifest and make it work on the second cluster. Anybody have any questions about this example? Okay. So with that being said, I kind of try to break everything down into specific use cases for transformations. And I think this kind of gets to your point, which is, there's like 4 buckets in my mind. There's the knowledge that is gained for a particular product team. So they know that they need specific things when they go from one cluster to another cluster for their specific product. This could be like an operator or a Helm chart. Maybe they know exactly what they need to do to transform it from one cluster to another. The knowledge gained from a customer in their particular environment. I think this gets to the question earlier, which is like, you sometimes need new labels, or they know that the new environment has this new thing that they need to add or change this value. Those are all like very real things that people need to do. There's knowledge that's gained by a particular platform. So this kind of idea is going from like EKS to an OpenShift dedicated cluster or something along those lines. There's I don't know, EKS to GKE, something along these lines, right? Like these clusters are not interchangeable. They are definitely different distributions of Kubernetes, and they have minor differences that make them that make it challenging to take an exported amount of data from one cluster and bring it right into the second cluster. So we have to make some changes to make that work. And then there's also like the upstream users that like for upstream projects that they know that like the project that they have that needs these certain transformations. And this could be something like GVK related, or even knowing like my app needs a specific ingress to work, something along those lines. So I'll pause again here. Do these use cases make sense? I'd like to spend some time on these if anybody has any questions.
Sean, does that also include translations between the versions? Like, for example, if you're going from 1.9 to 1.20, the deployment needs to change from V1 beta 1 to V1.
So yes, it does. But I think yes, it does include that. I do think that is I have a lot more slides on that particular problem that I want to get to. But the like GVK translation problem is definitely part of this. Yes.
Okay.
Yeah.
And Sean, the other use case we ran into it for, at least for MotoCube, is using the data from within a particular YAML file to modify itself. For example, in one of the cases we ran into, it was like a build config, which was using something like just a Docker file build. They wanted to change the build strategy based on the service name and the image name and stuff. It was a very unique use case. Basically, if you have to abstract it out, it goes like this, right? You have some fields in the YAML which you have to read, and then based on that, change some other field values.
Mm-hmm. Yeah, that seems like a pretty specific customer wants to change a thing for their particular environment use case. Yeah.
Right.
Yeah. Okay. Yeah, I agree. Like, I think that's an exact example of this, right? Like they're moving from one cluster to another cluster, they know they need to change some things based on some value or something else. I think that that's a very that's a use case that we have to be able to support. Okay, so I think then we're all in agreement that these cover the use cases for transformations. Does anybody have another use case that I've missed that doesn't fall into one of these 4 buckets?
Sean, just to give a preview, actually, Hari also has a set of slides which has something similar, but we can get to that later after finishing all the slides. Like it talks about, he talks it from a different perspective of features of transformation tools that we can talk about later.
Yeah, I think so. I think like that probably gets into my next slide, but what I'm trying to do is make sure that we all agree that these are the use cases that we need to cover, and there's not missing use cases here. I want to make sure that we all agree that we're solving that this is the set of problems that we would like to solve with a set of transformation tooling. If we end up deciding to end up using a similar set of tools or some sort of shared thing, like these are the use cases that we would be attempting to solve.
Sure.
Okay, so this is my quick stab at any goals for a transform system. So effectively, one of the I'm going to start from the right because I think that that's the most interesting, or some of the more interesting ones, and then we'll get to the end where I probably need to explain the left one the most. So reproducible and retriable, basically anything that is done in a transformation should be able to be redone every single time. There should always be the ability to start from a known set of things and recreate them, basically rerun the transformation to get the same output based on the same inputs. The immutable states kind of play into this, which is that we shouldn't overwrite data. We should create a new set of data for somebody to use from the transform. So the idea is that given a set of inputs, we can create a set of transformations, and then we can apply those set transformations to the input and end up with some output that can be used. This would allow somebody to change whatever they need to change at any given step, either add or subtract transformations, or do whatever they need to do to actually get their app running in the new cluster. The third one here is simple to extend or mutate before or after applying. It kind of goes to the immutable states. We want to definitely make sure that at every given stage, a customer has the ability to see what's going to happen, to change what's going to happen, and to affect the output at the end. I think it's really important that we allow somebody to have the ability to make one-off tweaks for whatever they need for their own environment, because all environments are like slightly different from each other. And trying to codify something for all different environments seems like a losing battle. Instead, we should give customers the tools to do the right thing for their environment. And that goes to the last one, which is that I think that we need a way for disparate actors to be able to contribute transformations for their particular use case. So for instance, the OpenShift dedicated team probably knows the best way to go from EKS to OpenShift dedicated because they are running OpenShift dedicated. They should be able to provide us a list of transformations that need to happen when going from EKS to OpenShift dedicated in such a way that we could be able to add that to a list, to a running set of transformations that like maybe we run every time, and then be able to add these transformations to that list of transformations to be able to apply it. The idea that I have is that we would have some sort of like ecosystem of transformations that would allow us to compose transformations together so that customers can either add their own or use a list of known good ones in such a way that they can build up the things that they need to do for transformations based on all of the information that they have. So do these goals seem like a good set of goals to talk about? And like to like focus on when we talk about transformations?
Yeah, it makes sense to me. I think this may be what you're thinking about. It would be really useful, I think, for any transformation system to be able to, without having to run it in some larger tool, be able to see what the transformation would produce given some input data so that you could quickly iterate on your transformation if you were writing your own custom transformation, like if you're trying to figure out how to codify your transformation knowledge. I'm just thinking of MTC, where today our transformations are only really accessible if you run a migration, which is not ideal for developing a transformation.
Mm-hmm.
Yeah, it's almost like a discovery, you know, and you're presented with options or at least some data that you can react against.
Can you explain a little bit more about that one, Brett? I'm a little confused. Sorry.
Yeah, I'll say if you want to go from, say, a source to a target cluster, and this kind of touches base back to a little bit of the work that we had with CPMA, but in the whole thought process around that was to, before migration or transformation of an application, it's more about what do we have on the source cluster versus what we have on the target cluster, what could be potential barriers there for migrating or transforming. It's more just providing more data to the consumer before they go down that path.
I think the problem that I'm trying to like to express with that is that we literally don't know what those are going to be because there's so many different flavors of Kubernetes clusters. There's so many itty bitty things that can be different that like we're never going to get that problem correct. So even attempting to solve that problem is just going to create a false sense of security where things are going to go wrong. Instead, I think it makes sense to not try to be in the business of saying like these will always work. We should be in the business of saying, hey, like these are the known good things for this particular use case, and then you can adapt them as you see fit, rather than trying to solve this problem generically. I think is going to just be a losing fight, I guess. Like every day there's new ingress routers, every day there's new APIs, like CSI drivers, there's new all sorts of things, and all of these require maybe slightly different annotations or slightly different incantations of the resources.
It's weird. Yes, better.
Okay. Sorry about that. So that's where my head's at. Does that make sense to anybody? Like, is
Sean,
that...
I think so. So I'm on
Yeah.
the same thing. Like, is kind of going to what Derek was talking about. I feel that if we look at the MTC case, we had a lot of great knowledge that was very hard to tap into and use, because the only way to access that knowledge was you needed the full entire workflow to be successful. This way, the transform logic that's embedded inside of the Go code in Valero could run. And what I see on this proposal is that we're kind of saying that the community as a whole is going to have this kind of problem of here's one cluster to another cluster. We're going to translate some stuff. We are right up front saying this is not an easy button that's going to work 100% of the time for every single imagined thing anywhere. We believe that's not possible to solve. But we think that this is something that can definitely be automated at scale for a known set of problems. And there's tons of knowledge that can be shared.
Yes.
So if we do something and break that out and get that knowledge into something that's small, that's easy to see, and then have folks be able to contribute on different patterns of it. And then at this point, if we can kind of agree that what we see going forward is probably this approach is like a functional approach. This way things are immutable. It's easier to understand what's going on, and then call out right in the beginning that you need to be able to see what's happening here. So you need to be able to see, this is my source thing. This is the rule or transform or whatever we call it that's going to run. And then here's the output. And if we get that kind of model, from what we know as of right now, it seems like that model will set us up the best for success. And I think at the point of this call is kind of seeing, does that model make sense? Is there something else that's better? Are we missing part of the problem?
Yeah, and I think the other piece that I would add to that is they need to be composable. So you need to be able to pick and choose which ones you use, be able to like put them into like the at scale statement you made. I think the whole like the other piece of that is that you can pick and choose what you need to add, and then that can be run over and over and over and over and over again. You can compose those together in a way that like you get to choose what you're running at what time.
The composability thing is really cool. One potential issue I see is if you start to get a bunch of transformations written by different people who weren't considering each other's transformations, writing their own, they could have conflicting effects. So I think maybe it would be cool to consider some way to be able to understand the effect that each individual transformation is having as it sort of travels through the pipeline of composed transformations, so that you could troubleshoot if something weird is going on when you try to compose. Maybe it's a thought for a little farther down the path than we're talking about right now, but anyways.
I think that's a really good point, Derek. I think that's probably a goal of the system, is to, if we're going to make a composable system, that we need the ability to probably allow the user to choose which one they want to take. Eventually that could be like, they can go and update the immutable state and then rerun it, but they could, eventually maybe we can make that a much better user experience. I think that's a good point.
Yeah, so there could be some, like, since we're going down the path of creating composable tools, we if these transforms are present in a directory, and if we know that they are acting on a particular GVK in a non-compatible way, that tool can detect it and give a better user experience, right? Like, we don't have to solve that problem in one utility, but yes, 100% a problem that can be solved.
So this is the at this point I have another set of slides that are devoted to like the GVK problem in particular. I did a bunch of research on that, but I think for this particular problem, if we're focused on these goals, maybe it makes sense to hand this over to the Move to Cube folks. And it sounded like you guys had some slides that you also want to present. So I want to give you the opportunity to do that if we're still talking about this right now. And why is my mouse not working? That's fun.
Sure, Sean. Thank you. Hari, do you want to quickly present? So basically, this is based on the last comment that we made in the previous session. In MotoCube, we have some capabilities around this that we required for some of our interactions with our clients. And so we had developed something, and we had done some evaluation of JSON Patch, Kustomize, and Starlark for it. We ended up using Starlark, but we would like to put whatever understanding we had and get the opinions, and if we can mutually benefit out of it. This does not get into the JVK problem, so I think this is a good segue out of it. Hari, over to you.
Sorry, I had it on mute. Can you hear me? Hello?
Yes, we can.
Can you see the slides?
Yes.
Okay. So hi everyone. So we'll just go through some ways that we can do transformations on Kubernetes YAMLs. So we are mainly looking at 3 different ways in this slides. One is JSON Patch. This is a way to modify any JSON document. It can be, there's an extension for YAML. Or you can convert between JSON and YAML, right? So it's basically the same. And second is Kustomize. This is the most popular. It's already shipped in kubectl, and it uses JSON Patch syntax. And it adds some extra functionality, like ability to set common labels, annotations, and even the ability to conditionally change some image names with new image names and so on. It also adds functionality like adding prefixes, suffixes. So this is an example. These are examples, and we implemented also some Starlark. This is a Python-like language. It's almost exactly Python. It's a subset of Python. It also so we are using it to enable arbitrary transformations. So if you have some very complex transformation that uses if conditions, for loops, and so on, you can use Starlark. It also allows you to read the input you're getting and do the transformation based on the input. So we're just comparing them here. So these are the capabilities. This is a JSON Patch, Kustomize, and Starlark. By JSON Patch, I mean outside of Kustomize, just JSON Patch alone. And Kustomize can use JSON Patch. So setting prefixes and suffixes, JSON Patch doesn't really have support for that. Kustomize does have support for it, but in a limited sense. I think you can change some transformer configuration to. Usually it allows you to set a prefix and suffix or metadata name, but you can change some configuration, I think, to or modify other fields. Starlark has support for modifying any field and setting prefix and suffixes for anything. Second is changing values conditionally. So you need to be able to look at the input. So if you want to look at the input and see what the image name is or service name, and then take some action based on that conditionally. So JSON Patch again doesn't have much support for it. Kustomize also, but Starlark has full support for it. So JSON Patch can test a single field and either accept or reject the entire set of patches. Kustomize can, yeah.
Can we just real fast? I'd like to jump in.
Oh, sure.
Yeah. So it sounds like what you're saying is if you just wrote a bunch of your own JSON patches, just JSON Patch itself, that you wouldn't be able to do some of these things. But that's not the only way to write JSON Patch, right? JSON Patch can be the way that you end up mutating files, but you could write the JSON Patch based on inputs and outputs that would allow you to do all of these things.
So you're talking about generating JSON patches on the fly.
Right. So like you would take a set of inputs.
Oh, sure.
Create a set of transformations based on the set of inputs. Then you
right,
apply
but
this set of transformations.
Yeah, there's lots of ways JSON Patch can be used. So even if Starlark and Kustomize is using it, right? I'm just talking about in as a standalone thing, not in some framework. Just what is defined in the RFC for JSON Patch and in the simplest implementation, I guess.
So I think the context of this is like, at least in case of MotoCube, how we had to use as a third party or a user should be able to write everything that he wants to define into a file. And that is a complete definition of the transform, which can be applied to any set of YAMLs on the go.
Let's dive into that. Why would a user want to define all of this in a single file?
Any bunch of files, like a series of files.
Okay. Why would a user want to define something this complex in a file and not actually write some sort of script to do it? Some sort of actually testable piece of code?
Yeah, actually, that is the reason we ended up with Starlark, because that is almost a programming language. It's just that it does not have access to the file systems and stuff.
But
So
I would argue that ease of use is probably, from my point of view, it's probably the main criteria, because like if you take Ansible, that's why Ansible is so successful, right? It's because
Yeah.
I don't have to write code. I just write something very simplistic.
Yeah, I totally agree, Marco. I think Ansible is a great example where you have Ansible, but you also have testing on top of Ansible, right? You have to have something to actually be able to test when you apply and unapply things. And on top of that, right, like you have intermediate steps of Ansible, right? Like Ansible is the ability to apply Ansible multiple times to a given set of inputs and outputs that allow you to like run it. And you can like do like dry runs and things like this with Ansible, right? So I think like Ansible is easy to use, but there's also a lot of other things on top of Ansible that allow it to be useful in that sense. If Ansible by itself was just like always run, then it might be a more challenging user experience. Do you agree or no?
Oh yeah, definitely. But I think in this context, that's the problem to solve, is whatever solution we picked is from an end user point of view, it just has to be simple. Or because as you pointed out in the previous slides, if we want to build a community of people that provide a way to create those patches, it's an impossible problem to solve by ourselves. If it's hard, like it's going to be an uphill battle. That's all I'm saying.
Yeah, I think the other piece of that is if we are going to make a community of things, ease of use of the customer running the patches, I think, is much more important than ease of use of creating patches.
100%. Yeah, that's the same principle of an Ansible module, right? Like I'm not saying the module can be complex, but the use of the module is easy. So the use of it must be easy, not necessarily the creation of it. Totally agree.
Go. Yep, I agree with that. 100%.
So when you say the ease of use, would generating JSON patches on the fly using some sort of templating or scripts, would that be? I think that would be not that simple, right?
I mean, maybe this is a matter of taste, but what do you mean by not that simple? I guess.
I mean, from a ease of use perspective.
Why not?
I mean, compared to just like if you write the script to just modify the YAML itself instead of generating JSON patch to do the modification.
So if I write a script to modify the file itself,
it doesn't have to be a file. So it could be a dictionary, right? A Python dictionary or some mapping. So that would be more robust.
So we have a mapping, right? And then it applies to a file, but I don't know, like then when it applies to that file. Right,
so don't think of a file, but like a Kubernetes resource, because a single file could have multiple resources. So a single.
Okay, that's
that's how Starlark does it. Is just a Python script that takes a Kubernetes resource, and then it's just a dictionary, a Python dictionary, and you can modify it and then just return it. So that will get written out as a final output.
Okay, so let's just assume when I say file that we're talking about a Kubernetes resource.
Sure.
Is that okay? Yeah, okay. Because it's going to be hard for me to translate that in my head. Can we just make that assumption real fast?
Yeah.
Okay, cool. If we have a file and we apply a set of things against that file, are you saying that it overwrites that given resource?
No. So not applying. Just it's a Python dictionary, and you can do whatever you want. So if you want to replace something, yeah, you can do that. But if you want to just append something like a suffix or prepend some prefix, that could also, or you could even add a new field if. So, for example, the YAML may not contain every single field, right? Some fields are optional, so you might add a new optional field with. So, for example, container resource limits or something like that.
Yeah, probably, Harishan, do you think it will be worth if we just run through this quickly and then see a demo of what the current solution is, and then we will have a more concrete way of discussing this?
That's fine. I think that this, what I'm pushing back on is the idea that Kustomize and JSON Patch are no's in this given set of things. Just because, because it seems to me that what you're saying is, oh, I can't write a JSON patch to do some dynamic thing, and I don't know if that's the right layer to be discussing.
No, so just so what you said, like you can't write a JSON patch to do some dynamic thing. It does have limited functionality within JSON patch itself to do testing a single field and either applying or rejecting the entire set of patches. That is a dynamic thing, but the generating JSON patches on the fly, that's not part of JSON patch. It's like you're writing a new framework to generate JSON patches on the fly. So there are already tools like I think YTT. There are a few tools already, and you can write your own scripts. But that's like outside of the scope of this. It's not limited to JSON patch. At that point, you're adding in new things.
Yeah, I think.
I think the point that I was trying to get at is that is effectively what Starlark does. It's just a lot harder to test Starlark.
No, so it's why is it hard to test?
At the end of the day, right? You have a set of things that you're applying. It's effectively a scripting language that you're adding a bunch of things to. Like you said, you have a dictionary, you're making decisions, you have all these contexts, and then you just put that in a single file and you add that file to the run. Seems to me that that in and of itself effectively is a script for all intents and purposes. And
yeah,
it's
so
not a scripting language. It's not like it seems to me that adds a layer of complexity on top of the problem of doing logic that maybe I would like to at least question right now.
So actually the reason we chose Starlark because it's easier to test. Like it's a scripting language is just easy to test, right? You can just test a unit, each function. You can have unit tests.
Okay. Yeah. So probably, Harry, I think once we get to the definitions of each one of them, we might be able to discuss the benefits and pros depending on the use case.
Sure. So I'll just go through the other things. Is like Starlark allows loops, and you can have arbitrary, more complex data structures like list maps. We also added functionality, so you can ask the user questions, so the transformation can be more of an interactive experience, which Kustomize and JSON Patch wouldn't have. Even if you generate it on the fly, I don't think you would be able to ask questions. So, well, maybe. So the other thing is targeting multiple Kubernetes resources. So just again, vanilla JSON Patch, you target a single document at a time, and Kustomize. They briefly added wildcard support, but then they removed it. So I don't currently you have to specify the group version kind and the name of the resource you're targeting.
Why did they remove it?
Yeah, they didn't. They said I don't remember the exact reason, but I can link you the GitHub issue if you later if you want. Yeah, they said.
It seems like that maybe is maybe they had a good reason for removing it.
Yeah. Yeah, but I don't remember the exact reason, but yeah, I can send you the link in Slack later. So Starlark can target multiple Kubernetes resources. We'll see how it does that, but it can use regex to. Or even just you can just give the group version kind without giving the name, and then it will target all deployments or something like that. And syntax, so JSON Patch is very simple syntax. Well, if you're generating it on the fly, then you need to know the scripting language or templating language that you're using. But just JSON Patch alone is a very simple syntax, but it might be verbose, but people are familiar with it. And Kustomize uses JSON Patch syntax and adds some more on top of that. It's also shipped with kubectl production. People are familiar with it. And Starlark, it's not, people are not familiar with it, but at least they're familiar with Python, I would think. So Python syntax, it supports, you can add support for JSON patch by passing in Go functions. So you can pass in a JSON patch library, and then it can have access to those syntaxes. And
do you mean a binary?
No. So you can pass in just a Go function itself, like a single function, like literally a single function or a set of functions. Yeah.
So basically, Starlark can be invoked from inside Go, and when you invoke Starlark scripts from inside Go, you can pass a Go function object to it to be invoked.
As long as the Go function is built with whatever tool is running the set of Kustomize, right? You're saying like the binary that you could pass in things in one binary, you could pass in things to the Kustomize call if you're calling Kustomize from inside that binary.
Yeah.
Okay.
So yeah,
it's not like a customer can write a Go function.
No, so you would have to change the binary, change the code and recombine. Yeah.
Okay.
But it does give some powerful functionality, like regex libraries. You can get access to that, or different parser libraries and so on. So it makes it much more powerful. And the syntax is simple for simple transformation. So if you are doing just a simple replace or add or remove, it's almost as simple as JSON patch and so on. But complex transformations might require some knowledge about Python, Starlark, so for loops and so on. So just brief information about JSON patch. It's a list of operations. You specify each operation has 3 values. The operation itself, whether it's an add, replace, remove, copy, move, or test. Then you also have to specify a path. So in the document, at what point you want to make the change. The second, and in some operations like copy and move, you have to give 2 paths, right? Where to copy from and where to copy to. And you also specify the value. So if you're adding something, you specify what value you're adding, or replacing, you specify the value. It also has a test operation for testing a specific field for a value, and then you can decide to either reject or apply the entire set of transformations. It's a simple syntax, but might be verbose. It's rather limited, I think. For example, prefixes and suffixes, like you would have to generate a JSON patch on the fly. So this is what it looks like. This is a HTTP request. It uses the patch method. And this is the body of it, right? You can see a list of operations, patches you're applying. Each patch has 3 values of path and value. Yeah. I think this is self-explanatory. So we'll move on to Kustomize, which already shipping with kubectl. It's a major part of the ecosystem. It supports JSON patch syntax. It has its own YAML or strategic merge syntax. So what the merge syntax is instead of using JSON patch to specify the patch, you take the original document you're modifying, and you only specify the fields that you're modifying. So like a container name or container image name, you would only specify just the bare minimum to specify that set of fields. It's maybe more user friendly. It depends what you want to choose, and it also has some a list of transformers. So like image name transformer, prefix suffix transformer, add common label annotations transformers, and all of these are built-in sort of hard-coded transformers that you can use for common operations. Yeah, so this is an example. We are adding a name prefix for a dev environment or a suffix, which version, some common labels. We can add some common annotations. We can look for a specific image name and replace that with a new image name at every location that it has it. And it also supports overlays. So what overlays are is that you have base folders. So this would be like your project 1, project 2, and so on. These are or microservices. So these are like the full project specification. All the YAMLs, Kubernetes YAMLs, everything is in there in the bases. And the overlays are for each environment, I guess, or whatever you want. So this will only contain the changes you want to make to the base. So you'll take the overlay and apply it to a base. And whatever changes are specified will be applied on top of it. It will override the base values. So yeah, so I think everybody's familiar with it. So I can move on to Starlark. It's originally a part of the Bazel build system. That's why it was developed. It was called Skylark. It's used intended as a configuration language. It has the advantage of being a subset of Python. So all the ease of use and familiarity with Python transfers over. But it doesn't have the security issue. So Python has full control of the system it's running on, right? So unless you run it in a sandbox, like it can access the network, the file system. It can make all sorts of changes and so on. But Starlark, it runs in a sandbox by design. So it's hermetic. So what that means, it can't touch anything, the file system or network files. So it's safe to run arbitrary transformations without having to worry about security issues. It can only read the stuff that you pass in, and then whatever stuff it generates, we have to manually extract it out of that sandbox. It gives you access to all conditionals, loops, arrays, maps, everything from Python, functions, list comprehension. So you guys were mentioning transforms, ability to compose transformations. So you can just do the same normal programming thing of writing functions and composing functions together to make more complex transformations, right? So that's one of the advantages. Also, list comprehensions, dictionary comprehensions, everything. So if you know Python, then it has a very low learning curve. Except you only need to know the extra things that that we added, right? So if we didn't add any new syntax, so you don't have to learn any new syntax. It's just learn some very basic the API that we are providing, basically. So instead of searching how to do something in Starlark, you can search how to do it in Python if you ever get stuck. So it allows arbitrary complex transformations. Yeah, so I think I covered most of the. Yeah, it has great tooling support, like VS Code plugins and linters, parsers. And also you can write unit tests for each function separately, right? So you mentioned we should be able to write tests for these transformations to know that they're working correctly. So the Starlark is very easy to test, right? You can test even individual functions or the entire module and so on. And the other thing is, yeah, so you can do dry runs. I think, yeah, it gives descriptive error messages. It has, yeah, so you even have a debugger, right? So you can debug the scripts. Yeah, and yeah, so it's hermetic, deterministic. So that was the other thing that was mentioned. the transformation, if you run the same transformation again with the same input, it should do the same thing. So it should give the same output. So it's deterministic, so you don't have to worry about that. It doesn't have access to any random library or time library, so it can't do any non-deterministic things. It gives you powerful string manipulation functions from Python, basically, and it has a REPL. It can be easily embedded into other programs. So we have embedded it into MultiCube. The execution is finite, so it doesn't allow recursion, unbounded loop, so you don't have to worry about that either. It's suitable for highly parallelized, right? It doesn't have any issues with multi-threading and concurrency. So you can run all the transformations at once if they're not running in series. So they can also be split into multiple files, and you can load another module into this Starlark module. And it's already being used, by the way. It's used by the YTT tool to some extent. It has support for Starlark. So this is what an example might look like. So you have some transformations. They're specified as functions here. Each function, it takes the input. So this would be a Kubernetes resource. It's a Python dictionary or Starlark dictionary. And here we're just modifying it and returning it as is. And this is the important part. This is what we expect, right? So here you can put whatever you want, but this is what we want in MultiCube. We want the outputs global variable with, it's just a dictionary with the key transforms, which has a list of transformations in the order you want to run them. So you specify the name of the function and so this is how we specify which resources to run on. So you can filter out, you can specify multiple filters here. So you can say deployment apps v1. Here you can even use the regex. So run. And this is another example. Here we are asking the user a question. And based on the question, we can take the answer of the question and use it in the transformation. So it can be interactive. That's all I wanted to express. And now we can go to demo, but if anybody has any questions.
Sorry, probably let's get some feedback on, or answer some questions before we get
there. I do have one question. Like, this is a great comparison of all the tools from a technical point of view, but has anybody looked into, like, sorry if I'm thinking like a PM, but like market traction, how many people are using those tools, what's available online from a community point of view, like that kind of data? Like, I'm just quickly Googling all, like, and it's funny, like, how the presence online is completely different from one tool to another.
So I can talk about these three. So Kustomize is already shipping with kubectl apply K -K. So people are already using it in production. People are familiar with it. Starlark is it's shipping with the Bazel build tool. It's from Google, and it's also shipping with the YTT templating tool. But our use of Starlark is more I guess a custom, I guess. So you might have to you'll have to learn what our API that MultiCube is providing. So we saw, like, we have a specific format, right? Like we expect outputs global variable. So some small stuff you'll have to learn. So other than that, so JSON Patch, I mean, Kustomize uses JSON Patch. So people are using JSON Patch with Kustomize to modify resources already. So in that way, it's already being used.
So, but if I Google all options, right, Kustomize, like I get to a website with a lot of examples, some tutorials, guides, documentation. It's really, really well done online. If I Google Starlark as an example, I cannot find anything. Is it because I'm not going to the right sites, or Like, is it because there's a
Um,
lot more traction on, for example, on Kustomize versus Starlark? I'm just curious, like, or is it just me doesn't know how to Google?
yeah, so there is documentation. This is a specification of it, but I think here docs Basil build. They have a complete documentation of the language itself, and everything is there.
So yeah, I think the other part is like basically since Starlark is essentially Python with just some libraries missing.
Okay.
So that's probably the reason there are not many examples.
Okay.
Yeah, so examples. So that's why I mentioned in. I think, like, if you want to find out how to do something in Starlark, you could also search. You could also search how to do it in Python. So, for example, string transformations, like, you could search how to do it in Python, and it would be the same in Starlark, right? Um, and there is documentation as well for the Starlark reference, and so yeah, it's not as specific to Kubernetes, but here you have the entire language.
So we're
Thank you. I'll keep doing research. Yeah, this is good. But thanks for the comparison. That's really helpful. Sorry,
yes.
go ahead.
No.
Thanks.
I was just going to say we're down to like 2 minutes left.
Oh, sure. Can I go to the transformation? So just want to give a good demo.
Well, I mean that's the question. I before we lose people, I just wanted to see sort of before we go. We can do a demo here and see where we go. Folks are probably going to start dropping off. But I didn't know if we should talk about sort of what the next steps here. I don't know if, like, obviously there's more conversation that needs to happen here, but I'd rather see us talk a few minutes about that before we lose people.
Sure.
So Sean, John, Ashok, I mean, what do you guys see as, obviously we want to kind of continue this conversation and get to some understanding. I mean, what's required here? What are the next steps that need to happen? Any thoughts?
So I just want to mention, like, Multicube also generates customized artifacts now. So it has both Kustomize and Starlark.
So what I see here is that ignoring anything that exists, it's a problem for the community. Is kind of, I guess there's a high level thing is that, do we think there is a problem in the community where it's worth to try to pool efforts together, where we could do something of, say that somebody has an EKS cluster going to Rancher, or something else going to, I don't know, whatever it is. Do we want to try to pull knowledge like that into some repo that could be leveraged? And I guess, because I don't even know if we got that in this call of just, is there a desire of trying to pull things together where we could have something that's common, where folks can kind of go together and then share this? Because if there's not, then the other thing too is just that tools use whatever they want to use.
Yeah, well, I mean, I think I mean, my vote there would be, unless there's a really good reason for us not to, as a community, to get around, if it's the same problem we're solving, why would we go and try to solve it two different ways?
Okay.
That just doesn't seem to be, I mean, there's got to be a good reason why we would be doing that if we did. Because at the end of the day, I mean, I would think the power of the community is us coming together and putting brain power in one direction.
Okay.
At least that's my viewpoint. I don't know if anybody else thinks anything different, but that's sort of what I would think.
I would make an argument that one of the things that we need to talk about, I think, is there's a distinction between, like, so Kustomize really works really well for when you have, like, your GitOps repo and you have, like, a bunch of resources that are that you're going to go install, and then it can overlay things on top of them. I don't know if it works as well for, like, an exported set of resources and what all of those things mean. I don't know if it works as well for when you have to determine, oh, this thing doesn't get applied versus that thing gets applied. So Kustomize has issues there. I think, you know, Starlark seems to have, like, some ability to, like, make decisions, but how do we how do you make Starlark something that like, I think the open question I have on Starlark is how do you make it accessible, and then like how do you make it shareable in a way that would actually work for like an EKS to OpenShift dedicated.
Yeah, and just to add on to you, Sean, and that one, if it's a programming language, it does sound, there's some concern at least that we need to make sure we're not just hiding, is that it's fine for everybody that's on the call probably to do this. It's not going to be a problem. But if we want admins and operators to be doing this, is it going to be a barrier?
And the next point I was going to make is what kind of experience can we write if we hide the details of the whatever method we use to transform, and instead make shareable pieces of like plugins that run together to do this instead, and then we make like an interface, and then we can make like a runner that will be able to do this. And I think that's the next set of questions that I'd like for us to go down, is maybe ignore the underlying implementation of how things get transformed and talk about like the overall user experience that we want to give, and then go from there. But I don't know. Like,
so should we? So in the interest of time, we're obviously out of time. Should we, rather than? I mean, I think this is a good conversation that we should continue to keep going. Should we schedule something, you know, kind of an ad hoc one of these calls and not wait another month? You know, I'm open to scheduling a call next week, and we can just continue this discussion if that makes sense. You know, thoughts?
I think that makes sense.
Okay, so let's pause here. I will work on getting something on the schedule. Hopefully we can do that next week, and then we'll just kind of continue this conversation until we get to a point where folks are comfortable. And again, from my perspective, if there is you know, if we are trying to solve similar problems, which I think we are, but maybe we're not. I just want there to be good reasons why we're making the decisions that we're making, especially if we choose not to use the same solution. But I like your point, Sean, of trying to make sure that we're focusing on the problem, the experience, before we get too heavy down in the weeds of exactly the technology that we're going to solve or use to solve it. So anyway, I appreciate it. I think it's been a good discussion. I'm going to cut it here. Look for an invite to come out, and we'll try to do something next week and continue this conversation. So thanks, everybody.
All right, just a second, Todd.
Yep.
Thanks.
Yeah, because we don't have time for the OPPO presentation, can we schedule that for next Wednesday as well? Or the next meeting slot you're going to find for?
I think what we'll do is we'll leave, rather than put that on the next meeting, I think we'll leave that as an agenda item for next the end of next month, unless there's a reason to pull that in. I'm just concerned that if we move it to next week, we're probably got at least another hour of conversation in this discussion, and I'd hate to bump you again. Does that make sense?
Yeah, sure.
Okay. All right. Thanks, everybody.
Cheers.